How you doing, everyone? I'm Sean O'Kane with Chip Estimate TV, and welcome to the 55th Annual Design Automation Conference here in San Francisco, California. ChipEstimate.com. We're an IP portal, an ecosystem comprised of over 200 of the world's largest IP suppliers and foundries, and we're all working together to help designers like yourself and the folks here at DAC to get to market quicker and to find the most up-to-date silicon-proven IP available on the market today, and that's where they can find it on ChipEstimate.com. And what we do is we bring designers and IP providers together very early in the design process. With me today is Lana Chan, Senior Product Marketing Manager at Cadence Design Systems. Thank you for joining us.
Sean.
Cadence also lists all their IP catalog on ChipEstimate.com. Our subject today is PCIe Gen 5 and the entrance into the battle of the high-speed protocols. It's almost like a battle there. So this will be covering design and verification challenges for PCIe C6, OpenCAPI, and Gen Z. Lana, first question is, who are the players in this battle, and why is it important, and what is driving the need for higher speeds?
So if we think about it, in the last 10, 15 years, we've actually just had an explosion of data. Everyone talks about big data, talks about mobile devices, IoT. All of these means that we're generating data, we're also consuming a lot of data. So what do we want to actually do with that data? Companies out there obviously want to be able to monetize it. Mm-hmm. So they want to be able to do machine learning on it, do analytics on that, actually solve complex problems from the medical field, even just automation of your factories. You're just getting a huge amount of data. And so if you're looking at the data center, you're getting all this data coming in, and if you have a pipe that's actually small, the processor has actually done its job. We've, Moore's Law, we've had a chance to actually put in more transistors in, but there's only so much you can do. If your pipe itself is very small, you're not going to be able to get the data through, and that's where interconnects like PCIe, like C6, like Gen Z, OpenCAPI, that's where that comes into play.
Okay. So what are some of the newer developments this past year?
So the biggest development would actually be last year at the PCIe SIG Developers Conference. They said, oh, fantastic, we have Gen 4. A little anticlimactic because they also said, by the way, we actually now have Gen 5, which is operating at 32 gig versus 16 gig.
Right.
Why is that such a big deal? Well, we had C6 who came in around last year and said, you know what, PCIe has been a little lagging. It took them about almost 4 years in order to get 16 gig. And C6 came in and said, you know what, guys, we're going to do 16. We're going to actually put in 20 and 25 gig. And in fact, we're actually planning on doing 56 gig. So of course, the data center guys and everybody out there in the market go, hey, you know what, that definitely answers our answer. But then, of course, PCIe is everywhere. It's ubiquitous.
Right.
You have it in your laptop, your mobile devices, you name it, it's there. The ecosystem's there. So who's driving PCIe? Predominantly Intel. Then you have the AMDs, IBM, HP. They all want to make sure they get a piece of that market. And of course, we're all engineers. We want to see what the latest and greatest is. How you can be more efficient. Right.
And customers are always looking for higher bandwidth and higher performance applications for like AI, machine learning, storage, high performance networks, just to name a few. So how does PCIe Gen 5 fit into this, and why is it important?
Why is it important? So at 32 gig, we've actually just opened up the pipe, doubled the pipe. That's pretty much how PCIe has worked in the past. So it's building on that ecosystem. Once again, like I mentioned, we've went from Gen 1, about 15, 20 years ago, all the way up now to Gen 5, which is 32 gig. You're still working on the same software stack. Everybody who knows how to work with PCIe can still do that. You're not switching up that at all. One of the benefits is the fact that you have these data centers in which you can, okay, I have a Gen 4 design, I'm going to switch it out. My software guys don't really have to do much on it. people know how to design a board for PCIe. Now, I'll talk a little bit as to what the challenges are for Gen 4 and for Gen 5, but by and large, it's an easy entrance into it. And if you look at C6 as well, they actually built on top of PCIe. So once again, the ecosystem is there. OpenCAPI, Gen Z, they're coming into this and going, you know what, we have a better solution. But with that, you're going to actually take on the overhead of having different upper layers, different protocol stack. People have to learn different things in order to actually implement it, not only at the chip level, but also at the system level.
Right, right. Moving forward, what are the challenges for design and verification for PCIe?
For PCIe, specifically what it is that PCIe has always been known as a solution that was pretty efficient in terms of power, pretty efficient in terms of, and cheap in terms of design. The board material, you could get away with actually doing your designs on very cheap materials. As we move to the higher speeds, the reach of the signal is going to be degrading, and as such, your board designers are going to actually have to use more expensive materials. They're going to have to get more creative in terms of dealing with signal to noise ratios and everything, and not having that deteriorate. What's also new is what was introduced in Gen 3, and which is going to be absolutely required for Gen 4 and Gen 5 moving on, is a device called a retimer. Think of it as a repeater. You know, I shout to you, you know, and you shout to somebody else. You know,
and it's not degraded.
It's not degraded. When you're talking at the speeds at 32 gigs, you know, you're sending an extremely short period of time that you have to be able to get that bit of information across, and that will degrade. And how do you know, ensure the integrity of that? That's where the retimer comes in. So that's an extra piece of device that you have to put on the board. It's going to be $10, $25, however much it is, right on top of the board cost. And so that's from a physical design perspective. That's actually something that the ecosystem will have to think about.
Perfect. Thank you so much. For all your design and verification needs, where do you go? Cadence.com. Yes. So for Lana Chen, my name is Sean O'Kane. Thank you for joining us here at Design Automation Conference 2018.